And we are now recording, and thanks everybody for participating in the webinar today. Hopefully nobody's going to be turned away who has signed up, but we are pretty close to the limit. As I was explaining before, we welcome your questions and your points of view, and we welcome opposite points of view. There is a lot of skepticism about the whole mask initiative, and so those points of view need to be presented as well. So yeah, I see, Ross, that Catherine Passman just said she's having trouble getting in or D9. Yeah, so you can hopefully we can take care of that one way or another here.
Yeah, we'll take care of it.
Yeah. So yeah, I'm so sorry on these meetings full of things and so forth here, but the webinar today is going to be based on material that's already in the alerts for the last 4 or 5 days. In the alert yesterday, we talked about speed as the basis for the webinar, a push-pull program, validation of fitted mask efficiency, a 5-step approach, and then an example of Eurofins that's would be part of the quality test seal that's part of the 5-step approach. In that same alert yesterday, Lloyd Ambrust talked about the initiative they have to provide large quantities of melt blowns, and Lloyd is going to talk for a few minutes about that this morning. Then we're going to move on to the alert that we sent out on the 19th, and it includes some points by Dave Rousse, who's the president of INDA, and he has some very interesting surveys and conclusions about the impressive amount of melt blowns that is available. We have an ER doctor with us, Keith Delagrata, and he's going to be talking about a mobile device to ensure mask fit, and that's going to be very interesting as well. And then Eric Couch is going to be talking about the whole ASTM initiative and his view of how that can be used to make sure everybody is aware and is purchasing masks that'll make all the difference. And just a brief aside will be on the relationship between filtration area and breathing resistance, which I'm not necessarily has not been clarified for a lot of people. And I think the fact that N95 equivalent masks are being required elsewhere in the world is significant, and we'll just touch on that briefly. And then there's going to be a presentation by Sabrina Passaman, who has created what she calls the essential brace, and essentially then you can use a medical mask, put the brace on the outside and have the N95 equivalent. And so then we're going to get briefly into some of the others that might be other options that are available for fit testing, including thermal imaging. And then we'll get briefly into just 1 or 2 articles out of the January 15th alert. And essentially it will be just a summary of all the pros and con arguments here, and asking any of the participants if they would like to comment pro or con on any of those issues. So now we're moving along with the January 20th alert, and what we wrote there is try to address why the McIlvaine Company is taking it upon itself to help provide the speed and urgency. And we found that we have been helpful in over the decades in a number of different crises, and I would say this is in the same quantity or even more so than the Gulf oil spill. And we were right in the middle of a year-long study of dissolved oxygen sensors at the time of the Gulf oil spill. And so then we were able to get together NASA and the oil companies and all these different people in a matter of a few days.
I'm just going to
help.
Hang on. Somebody's got the mic on.
I think we got somebody on here who needs to
mic's on.
put on mute. But anyway, whether it was chemical or non-chemical O2 sensors, and who might be able to supply them for the subsea analysis of the spill. That turned out to be very valuable. We've done several of them that involved air problems or regulations, including the 1990 air regulations were about to be promulgated when everybody realized that all three methods for velocity measurement had flaws, and it turned out you had to use one method in one condition and another method in another, and on and on. So we had some very heated and very well-attended discussions on all that for a week or so. And when all the 2205 nickel halide scrubbers started failing and billions of dollars was at stake, we had many hours of discussions with everybody with people's views of what needed to be done. So anyway, that's our background and why we're doing what we're doing here. So we have kind of revised not honed our thinking, I guess I would say, to say with a push-pull program as a way to explain what might be the way to proceed here. And Eric Couch will be talking today about the Biden administration and the need to use ASTM labels to make it very, clear to the end user that it's something as simple as buying something in the 20 to 50% range or the 50 to 100% range. And he'll give us a lot of good points on why his approach is something that should be undertaken. So this is what this would be what we would call a push, that you've got regulators saying, you've got to have something that's got an ASTM minimum on it. There's also the pull, which is if you have a testing organization that is evaluating mass and provides comparative efficiencies and other things that and quality control, assurance, and so forth, you may want to go with a higher efficiency mask or one that's where the quality control has been assured. So that would be the pull or incentivized part of the push-pull system. And the result would be efficient mass for everyone. And so what incentives do individuals, universities, fitness centers, and malls have to require something more than the ASTM 50 to 100 level? And the answer is survival. Let's say occupancy and mask efficiency are directly proportional. As a theater operator, would you rather have 50% or 100% of the seats filled? So that basically, then I'm not going to skip this next paragraph, but if both the emitter and the transmitter and the recipient are wearing a given efficiency, you have a combined efficiency, and the result can be that you have a huge difference in protection, 9 time better protection with a 90% mask than with a 70% mask. So the pull safety level can be validated by I get I'm getting these notices here that we're full and I can't see the screen. The Eurofins is an example of what might be part of the pull level, and SGS is another worldwide organization that can do that. And we have to be sure we don't create a monopoly for a few large organizations like this that set these that create these seals. So various different combinations, like in Nelson Laboratories, can go to somebody like MPR or something and set up an equivalent as well. But just skipping down then to the sequence here, you've got manufacturing quality control, which your seal would tell you is being done properly by the manufacturer, the distribution quality control. Separately, you'd have the ASTM label, but then you have a testing quality seal based on, all these different things. But you really, at the end, need fit inspection at the end if you're walking into a building to make sure that you have a mask that fits. And then this would be the 5-step program that would provide efficient masks for everybody. And so this fit inspection is the last step, but it's a very challenging one, and I'm sure we're going to have lots of controversy on all that. But then just to explain what the tested quality seal is, that the one that's being offered right now by Eurofins, shows that all these different items have been tested by them, and we won't go into all the details there, but you can see these are the different things that they would attest to that are part of that seal. And the seal would be relative to some standard, and it can be the standards that are actually required. So here are some of the standards that are actually required for public masks in various different countries. So that is pretty much that part of the program here. Would anybody like to comment at this point on that 5-step program? Give people a minute to think about whether now would be the time to say something on this, but if not, please feel free, if you get some ideas, just to interrupt where we are, because we want your feedback. I heard from ATI this morning, there are 2 ATIs, and so ATI test is different from the ATI that makes the mask respiratory resistance tester. So we probably should have clarified which ATI we were talking about. Now let's move on, and if Lloyd Ambrose is with us on the conference call today, Lloyd, maybe you'd like to walk us through what you're doing with melt blowns.
Yeah, thanks, Bob. I appreciate that. And this is an amazing amount of information. I hope and pray that the Biden administration has somebody on staff that has this level of expertise. Watching the inauguration yesterday, seeing more than half the people in cloth masks with poor PFE was just kind of killing me in terms of like their 100-day mask plan that they have. And I'm glad you touched on the plan for 70%. That's what I had written down right before. I really think if you're doing the scoring of 1 to 50 and 50 to 100, I really think it should be at 70, because most of the studies show that at 70%, if everyone wears a mask at 70%, then not even everybody, 70% of people, then as your data showed, it cuts down transmission tremendously. And I think that's the number that's very achievable. A simple surgical mask, even a bad surgical mask with a mask brace would be able to achieve that in most cases. I just wanted to comment on that because I'm just blown away by this. This is amazing. In terms of our melt blown, we set up, right away at the beginning of the pandemic. In fact, it was funny. I was talking to one of our mechanical engineers. If you want to trace the big issue with supply chain came down to not just the machine, the melt blown machine, which I had flagged in, January, I was like, we're going to run out of meltblown. But it was actually the die head on the meltblown machine. They couldn't make more meltblown machines quickly enough because there were only a couple of companies that make that die head that push the plastic out at a small enough amount to make that electrostatic filter that we need. And so I set out right away. I remember, I think it was February, we put in an order for our machine to start building. And we actually have 2 machines now. So the one that you have a picture there was our first machine. It's a 600 millimeter. It's a smaller one. It produces about 1 to 2 tons per week. But our other machine that's coming online is much bigger, and it produces about 1.6 tons per day. It's a 25 GSM thickness, and with our proprietary blend, we can get to about 98, 99% BFE, PFE. One thing I did want to sort of flag is as you pointed out, we produce primarily surgical masks here in our facility just outside of Austin, Texas. We're capable of producing up to 1 million masks per day. We actually don't have our facility on 3 shifts right now. We're on 1 shift, but we can flex up to 3 shifts would give us that number. And our masks are ASTM level 3. But something that we found interesting is even though, as I'm sure you well know, the ASTM level 3 needs to have a BFE, PFE of 98% or better. We actually have our own ASTM lab here with a PFE machine, and so we test our filters daily, and we use 0.1 micron latex particles for that, we're constantly in the 98 or above. But when we're testing other brands, and I don't know if they're getting, maybe if they're on an ocean voyage and they're getting, if there's humidity that's in the mix or something like that. We're actually seeing most ASTM level 3 masks when we put them on our machine at a 90% or 92%. Now that's probably splitting hairs because, according to the research, like you really need 70% or better. And I would be happy if I walked out on the street and saw everybody wearing a surgical mask, even if it wasn't ours. The other thing that this has allowed us to do has expanded by being vertically integrated has allowed us to make, I'm sure you've heard of these PM 2.5 filters that they put inside of a cloth mask, filter inserts. I believe we're the, I have them right here. They look like this. They're usually white. I believe we're the only company in the United States that's making these. And PM 2.5 blocks down to 2.5 microns. That's where the number comes from. So obviously isn't going to be very useful against the coronavirus. So we actually use our filter material and our spun bond here to make it. And so we call it a 2.5 plus because it's 25 times better than the standard PM 2.5. And also, I'm really excited to announce that we've gotten through and have just filed our application with NIST for our N95 cup machine. And we can produce N95 cup respirators. We're still in that NIOSH process, but we're being fast-tracked, I'm being told. So lots of exciting things. When you actually make the fabric yourself, there's a lot of opportunities to kind of experiment and build and play with different things. So I'm glad we were able to get that machine running. It was not an easy process, having never made a filter like that before. But it's exciting that it's actually live and in the world.
Well, thank you, Lloyd. And I think we'd like to have you on again to talk about your knowledge relative to electrostatic charging of the media. And certainly Peter Tsai now is talking about methods for more robust charging, and I know you're an expert in that area. So let's keep that in mind and ask you to come back here. Let's move on then. By the way, were there any questions for Lloyd? So didn't mean to cut off any questions for Lloyd. So we're going to expand then the webinar that the alert for the day for the 19th now, and so these are the headlines for it. And this was, again, we're going to skip that. But what we'd like to now do is turn to Dave Rousse, who is the president of INDA, and he provided this very valuable information for us on the status of meltblown here in the United States. So, Dave, let's hear a little bit more.
Okay, yeah, thank you, Bob, and glad to be part of this group. So INDA is Association of the Nonwoven Fabrics Industry. We've been very involved in the COVID-19 response since the beginning, since a lot of the personal protective equipment is based on nonwovens. Certainly face mask media, medical gowns, surgical gowns, the booties, the head wraps are all nonwoven based. So we were called into play early on in the pandemic to help the White House task force understand the supply chains and connect the White House task force with those in my industry who would be attracted to make investments if there were incentives in the form of investments and also in the form of assured demand. So we're still working on the assured demand with policymakers, but I do think that we were very effective triggering investments to alleviate the shortage of meltblown, which occurred immediately upon the pandemic when our Asian supply chain, which had been supplying 85% of face masks, of high performance face masks, medical, surgical, and N95s, got cut off overnight when the countries making them needed to devote that supply to their own needs. And we had a woefully short supply base here of the nonwovens needed to make those high quality face masks. And that's why people like Lloyd Armbrust jumped into the business. And we've tried to track how many people have been brought into the manufacture of meltblown in North America through relationships we have within the industry and following the media, et cetera. And I'm going to add one more machine here, Lloyd, since you've announced your second machine with 1.6 tons per day. So we'll put that in the mix as well. The bottom line is that the big push since March of last year to develop a North American US-based melt-blown capacity has been very successful. We have identified 34 lines, and I mentioned that it may now be only 29 as some have slowed down or tapped the brakes since they saw so many others getting into the business. But nevertheless, there's a substantial amount of new capacity of nonwoven coming up as we speak, and we expect by the third quarter of this year we'll be pretty well in place to satisfy the domestic need for this material to make high-performance face masks to deal with the pandemic. We've also seen a huge surge in the demand for these masks, and we made an estimate, and you can see it on the screen there, as to what this might be. When you balance the demand for the masks with the amount of meltblown that we've incented to come on stream, there is an imbalance. We're going to have more capacity than we think we're going to have a demand for face masks. However, we think that capacity is going to be absorbed. We think that this new ASTM level can absorb some of it as a non-N95, but still a high level of filtration efficiency performance with low pressure drop. And we also see that there are some building code changes or building practice changes due to the desire for higher indoor air quality at the level of MERV 13 or MERV 14. And to achieve those levels of indoor air quality, the indoor air filters are going to need some level of melt-blown, electrostatically charged melt-blown, to deliver that level of filtration efficiency while still maintaining a low pressure drop so that the fans and motors driving the air don't have to be upgraded as well. We've got a lot of capacity coming on stream, but I do believe that that it will be absorbed by face mask users and or the drive for higher indoor air quality. Now let me talk just a little bit about the ASTM standard being developed, which came out of a need we saw for conserving the melt-blown capacity we did have for the healthcare sector, which was deprived of their supply chain when Asia turned it off. There was not enough melt-blown to make all of the face masks needed by the public, as well as satisfy the demands for the healthcare sector, which went up with the pandemic. But we had a lot of other non-woven materials which do deliver filtration performance, but it wasn't electrostatically charged melt-blown, and we could have put that into the play. So we had a code name project called N80, playing off the N95, 95% filtration efficiency. We thought something in the 70, 80 level would bring into play a lot more media and deliver on the need the country had to have face masks in quantity for the general population. We went to NIOSH to see if they would help develop some kind of standard or qualification process for a, quote, N80 kind of a mask. The individual we talked to was very interested in it, but he said that that's not something NIOSH could do since they were involved in occupational health, not general public health, and that this would have to go through the ASTM process. We have some familiarity with the ASTM process. We found that to be a little bit of a block because it usually takes an awful long time to get a standard through ASTM. But our NIOSH contact said that he might be able to help on this. And we said, how? And he said, well, he was the chair of the ASTM committee, and he thinks this is worth pushing through. So he put full effort into it. And we're now in the final balloting process for that ASTM level specification. As with everything, compromises have to be made. So in this standard for a general public face mask, assuring some level of protection to the wearer as well as those around them, and having performance levels which enable it to be mass produced, has resulted in a performance standard with 2 levels of performance. Level 1 establishes a minimum filtration efficiency using the N95 test method, but different pass-fail, of 50% with a pressure drop of 15 millimeters of water or less. And the level 2, the higher level of protection, is a minimum filtration performance level of 70%. But here's the kicker. The pressure drop is going to be the more demanding performance element of a level 2 ASTM performance standard. That pressure drop has to be 5 millimeters of water or less. Now that is pretty difficult. That is pretty difficult to achieve without fine fiber electrostatically charged melt-blown. We have talked to some face mask makers who say we're going to have to solve for the pressure drop, 5 or less, and then we'll design for the pressure drop and then solve for the filtration. So there may be some level 2 masks out there that come in with a pressure drop of 5 or under with a filtration efficiency of 75, 85, maybe 90. We know of one media out there which is 96% filtration efficiency with 4 millimeter pressure drop, and that's with a new engineered material, not yet commercial, but that's the best we've seen out there. So the new standard, we think, will deliver assurance to the general population that they are going to get some protection from a face mask adhering to the ASTM levels. We're trying to get, and Eric will talk about this later, we're trying to get the Biden administration and the CDC to adopt the ASTM levels in their requests of the public to wear face masks, not just any face mask, but an ASTM level 1 or 2 to assure protection to themselves and protection to those around them. So with that, Bob, I'll stop and respond to questions or allow you to go on to your next presenter.
Yeah, let's have questions for Dave.
Hi, Dave. I have a question. This is Sri talking.
Hi, Sri.
I see that you mentioned the 274 million masks per month production capacity, and that's of course a moving target as lines come up and things change, demand changes, and so what Germany has recently announced is a public health measure to provide FFP2 masks to their senior citizens, 65 and older. Is that something that we can support here in the United States, or is that just well beyond anything we could imagine here doing?
Well, I'm sure others can respond to this as well, but I was impressed that this morning's news has the Biden administration using the Defense Production Act for a number of things. First, to distribute the vaccine more rapidly, but in it was also mentioned assuring production of an ample amount of high-performance face masks. So, Sri, the answer is probably. I mean, it could happen. I think they, being the Biden administration and their coronavirus task force, are early in their thoughts. They're still working things through, understanding the lay of the land that they inherited, and then imposing some of their objectives and finding out how to do it. So that's a possibility.
So it is, okay, so that's really good to know. So that it's not outside of the capacity that, if you did the numbers of 50 million people, so Germany is sending, allocating 12 masks for each of their senior citizens, about 34 million senior citizens. So in the US, that would be about 50 million people over 65. So if we did the math, would that work out in a way that are the numbers kind of in the right ballpark? Like 12 times 50,
Yeah. If something like that were to happen, the industry will respond. I mean, look how rapidly we got from almost zero meltblown to more than we need at this current time. But if the demand goes up, we can get more.
Yeah, I think France is considering it, and I think it's going to become very quickly seem like a rational approach.
Yeah, if it does, we will respond.
Dave, this is Lloyd. I'm curious, what do you think about the efficacy of doing something along the same lines, but rather than having to produce some of these N95s for old folks, for instead providing just simple surgical masks with a mask brace? Isn't that more efficient?
I do believe it could be more efficient since there's so much production of these rectangular masks with the ear loops, and you put the brace on there, and it establishes the tight fitness that's required for high efficiency and true protection. The comfort factor, I think, is going to be a driver of that.
Yeah, we're going to actually have a presentation on that here. In fact, a couple of them coming up on the brace, so we'll probably be able to answer those questions in that.
I was just gonna ask, like breathability, pressure drop, braces, humidity buildup, oxygen versus CO2 levels. Like how do we balance these things for older people, right? Especially with more sensitive facial geometries and more sensitive facial structures. I mean, we see people like ER doctors with facial ulcers from wearing these N95 masks all day, and older people get bed sores from lying in bed. I can't imagine that it'll be much better with these kind of face braces.
Yeah, we can comment on that. So we've been working very hard to make sure that these are comfortable for a lot of different varieties of faces. And the true innovation here is this nose cushion geometry. And the benefit there is that the reason why there's so much pressure, you see those terrible views of those healthcare workers with scars and marks on their faces, is because they're relying on the positive pressure aspect of it to shove it against their face. What we're doing instead actually is not relying on the tightness of the head strap to pull everything back. We're relying on this just sitting on top of the face. And that actually is low enough pressure so that it doesn't necessarily leave a mark in the short period of time. If you wear it all day, there are white marks, of course, but the actual pressure that you experience from this is actually a lot less than a typical N95 respirator. For the humidity and breathability aspect of it, when using a filter of a low pressure drop, and I'm sure other folks here can speak to this more, but surgical masks and just the melt blown used in surgical masks actually has a lower pressure drop generally than N95 respirators. And so not only is this solution potentially more breathable and allowing air to pass back through more easily, but also it is more comfortable for the length of time.
Yeah, Sabrina, maybe that would be a chance.
These big frames too, you know, like the issue that we were seeing with this is that, let me show you guys here. The issue that we saw with these face frames was more so that because of the way that they're shaped, like we actually gave a lot of these to retirement homes. And when we gave them to retirement homes, that was like one of the biggest issues that a lot of the even healthcare workers who were younger had. And so they didn't want to wear this thing with their surgical mask because of just how uncomfortable it was, because if they really wanted that tight seal on their face, they'd also have to put straps on it too that put a lot of pressure on the face, because it was put a few points of pressure on different parts of your face versus the N95, which evenly distributes around your face.
Yeah, thanks for sharing that. One thing I do want to caveat, like Bob, if you want us to keep us on track, Sabrina and I are happy to get to this later. Is that okay to you?
Yeah, I think maybe it's a very important point, but I think it's going to be better answered when you start displaying, because we're going to put up your full PowerPoint presentation so everyone will get a chance to see all this. But before we did leave that, I wanted to ask you and the others and Dave here that that filter area, you know, and obviously velocity varies. V equals P squared. So a very small change in the amount of filter area will greatly reduce the resistance. And so I think, Sabrina, in our conversations, you mentioned that there might be more filterable area with your brace design. Is that correct?
Yeah, so one of the benefits of this design, it maximizes the amount of area possible with the minimal amount of material. So we're very excited about the prospects here.
And I would ask Dave again here too, because, you know, I got thinking more and more about this when you kept emphasizing that 5 millimeters of water. But if there's a way, and with an internal brace or as well as an external brace or some other way to maximize the amount of filter media, then that's another dimension, I suppose, that needs to be pursued.
Well, yes, and let me go on record that the nonwovens industry is fully in favor of more area of filter media going forward. But seriously, yeah, you know, in our view, there's a lot of designing that has to be done. There will be more material science developments like we're talking about here, and more ways to innovate to solve the problem. There are many many factors which have to be balanced, and it's refreshing to see this discussion and how some of these challenges are being met already. And I look forward to your presentation on your device later on. We're early in the game, and I expect there'll be a lot of activity going forward.
Dave, one more question. You had mentioned, if I heard you correctly, I'm not sure I heard you correctly, but did you suggest that there was actually excess capacity currently for the melt blown, or is it still being completely consumed by the healthcare industry, or where does it stand in terms of the supply-demand balance?
It's pretty well in balance right now. There's more coming on, but we expect that it will be absorbed either in masks or in higher MERV filtration levels for indoor air quality. The indoor air quality initiative is very big right now, as well as the call for masks. There may be a time when masks will not be needed to the extent that they're needed now, but the indoor air quality needs will be there forever.
That's true. Yes, thank you.
Great, Dave. This is Eric Couch. I'd just like to interject in terms of the whole the whole discussion about capacity today of N95 meltblown and over time, I think all of us have the interest in immediately crushing this virus in a matter of weeks, which is a very different question than where we're going to be 6 months or a year down the road. And our job here, and I think the context for all our conversations, is to get the darn ball rolling, create the framework, get the national campaign going, and then build out our capacity and give people as high as possible protection as available over time. So when we talk about available capacity, I really want to distinguish the immediate short-term crush this virus over the next several months versus what happens 6 months or a year down the road.
Yeah, good point, Eric. The feedback we're getting is that those who need meltblown are finding it right now. So we're about in balance right now with more coming on.
That's very helpful. Thank you.
Yeah, I think we probably should move on now. We've got an ER doctor with us, Keith Delagrata, and he's got a very interesting concept that I'd like to have him explain to you here. Keith, the floor is yours.
Yeah, thank you so much. Nice to be chatting with everyone. I'm honored to be here. So, in addition to my work with M-Cubed AI, I'm an ER doctor as well in Los Angeles. So, I thank you for what all you guys are doing. And, I know firsthand, working in the ER, seeing both the travesties that come along with COVID from people not wearing masks appropriately or not having them be appropriately fitted or filtering masks. So all that we can do to change that, I'm very much excited for. So thank you for that. So I'd like to, just touch briefly upon what we're doing here with M-Cubed AI. So I'm co-founder of this. I'm going to hand it to my colleague as well shortly. But essentially, we developed this advanced 3D scanning analytics capabilities with just a cell phone camera to predict fit for masks and to help people find that good fit that we all know is necessary to help conquer the pandemic that we're a part of right now. And we've been able to partner with Vogue Mask, which we were very excited to partner with them because they're not only a very popular fabric cloth mask among the population, but they also have very high filtering capabilities. So they sort of do best of both worlds in that front. And we're going to be able to partner with them to really get the best fit for all their consumers. And I think there's a lot of applications for our technology. I wanted to hand it over to Jesse, who's the executive lead for our company. He initially came up with the idea for the company, and he's got an extensive 3D tech background, including at Amazon, so he can touch a little bit more on the technical capabilities of our company. I think you're on mute there, Jesse.
Well, howdy, everyone. Thank you all for everything you guys are doing in this space. I know a lot of you have been at this for a long while, and I respect the work that you guys have done, especially those trying to bring production and sovereignty in our supply chain back to America. I think this is something of critical importance, not just now, but in the future. And so I applaud all of you for what you guys are doing. And Sabrina and Catherine, I'm very excited to learn more about your mask bracing technology and see how you guys are trying to innovate there. But to get to what we're doing today, basically, I started this company at the outset of the pandemic because I have a real passion for 3D. And also my little brother is like Keith. He works at an ICU as a frontline doctor. But like me, he has a very uneven face. And he has a base that doesn't really fit the traditional N95 mask. And it turns out that the N95 masks that we have today are based on Caucasian males between the ages of 29 to 45, and it's 2 decades old. And so this means old people, young people, people of color, which, by the way, it turns out a lot of the frontline healthcare workers are persons of color, cannot get access to a mask that properly fits their face. And this isn't a matter of just, style or comfort. This is a matter of life and death. If it ain't airtight, you're not going to get as much protection. And so that's why we set about using the same technology I was working on at Amazon to be able to use just a few pictures and create really accurate 3D scans of your face together with computational fluid dynamic modeling, to be able to do simulations and also physical testing and measurements of people's faces and the fit of their N95 masks. And so today what we're doing is we're working with people like Bogmask so that we can help them help their customers figure out what size they are. The reason why we chose Bogmask to work with is because we're very impressed with the high integrity that they carry their brand with, the high standards that they adhere to, the ASTM level testing that they've done that many people have spoken to, and also the fact that they come in 5 different sizes so that they can accommodate a range of ages, sexes, and ethnicities. And so that's what we're working on. What we'd love to talk to people about today is if anyone here has any regulatory experience on how we can get the way that fit testing is done today, which is Byzantine, is purely Byzantine. Keith, how do they do N95 mask fit testing today?
So I can speak to that as a doctor, right? I mean, and you guys are probably all aware, right, with the N95 testing, where it's an annual test, mandated by OSHA, where we go in and they put a hood over our heads. We try on a bunch of different N95 masks and they spray essentially like a perfume or a bitter smell, whatever, right? And we have to breathe it in and tell the proctor, the person testing us, whether we can smell the odor or not, right? And so it's very subjective, and what we offer is potentially in a very objective way of doing it.
Using computer science. We started off here as part of sorry, that's my Alexa. She responds to computer, which is really confusing for me because I work in computer vision. But my girlfriend is very, very phobic of the word Alexa. Anyhow, that's what we're working on today. Other things that we've done in the past are creating custom 3D printed masks up to ASTM level 3 spec, using melt-blown fabrics as a filter medium. We've also been taking a look at the application of soft robotics to create dynamic geometry in real time. And we've also been taking a look at new oxygen generation technologies that are being developed here at Stanford using hydrogen fuel cell technology. So there's a range of things that we've been exploring, but really what we're focused on today is helping people get a mask that fits so that they get better protection. And we're really grateful for the opportunity to be partnering with Wendover and Mark to get this done.
Hey, Jesse, I just want to add to your remarks that this is a very necessary area to explore. In the ASTM committee work, the concept of fit, measuring fit, was the biggest challenge they had, so they essentially punted. It's very hard. It's a very hard issue to get around. So pleased to see you're doing some good work in this area. It is a problem.
We'd love to talk to you more. We tried to get in hold of the ASTM folks, and they basically big shotted us. They're like, "Who are you guys?"
Yeah, I think it's a very, very.
If you can connect with me offline, I can connect you with some folks.
Yeah, again, thank you guys all very much I'm just really, really excited to see all of us here together trying to tackle this problem nationally. I quit my job in big tech to come do this because I thought it was messed up that China had their control over America's life-saving PPE. And I think the work that everyone here on this call is doing today to create sovereignty domestic supply, on-demand, agile supply chains is absolutely critical and important. And the really cool innovations like what Sabrina and Catherine are working on, I think it's awesome. The more that we can get out there, the better we can make America, not just now, but future pandemics.
Thank you.
Go ahead.
Thank you, Jesse. This is Christine Sang, Waterloo Filtration Institute. I'm very excited for what you presented. I think I can see your passion behind it, because no matter how advanced the technology, how advanced of our materials, if we don't have a good fitness, we want to get the production as we designed for. So continue to do your work, and we as the media supplier or the filter manufacturer and from user side, we will do anything so we can do to support your efforts.
Oh, thank you very much, Christine. Really grateful.
Yeah, now, Christine, you might just mention that you're going to have February 23rd, you're going to have a mask and filter webinar at Waterloo Filtration Institute.
Yes, we actually share the passion as Bob started from very beginning, February last year. So we continue to broadcasting what's a new update with face mask, with air filtration, and also from manager's standpoint, building indoor air quality management and online monitoring. So on February 23rd, we are going to launch another webinar. We have been launching series of webinars last year. So this year, the first webinar, we were going to address cleaning air solutions in response to COVID-19. So as we know that if we want to get an air cleaning solution, not only require face mask, and Dave Rossi just mentioned indoor air quality, and there will be a huge demand how we keep the indoor air safe and clean to breathe. So like a face mask is to the filter to the human, but air filter is a mask to the buildings. So that will be tremendous demand on that. So Jesse, I think a couple of things is very similar to face mask, like fitness. But for air filter also, no matter how good, how efficient of your air filter, if you don't have a good method to ensure air tightening and also installation, so that won't work. So that's very similar how we ensure that we have the good technology, we have the good product, and also ensure how to use the production as we designed for.
Definitely. I think HVAC technology is the next application of the core IP that we've been building here. You know, the ability to 3D scan everything with great precision and to do it with just a few pictures, and then to create a high fidelity 3D model that you can use for simulated testing using computational fluid dynamic modeling is, I think, the real innovation here.
That'd be great, but I think this is also a very challenging job because you have face shape, all the things is different. And also one question, Jesse, while you're presenting, actually I tried to download the M3D app. Is that the only app for Apple, or is also available for Android?
So right now we have the MyMask Movement app for people that are using iPhones. And iPhone 10 or newer, but right now what we're also working on is our webcam-based app. So anyone that's looking at the camera right now will soon be able to get their size fitted and get a very accurate 3D model of their face with just 3 pictures.
That'd be great.
And that's actually what we'll be working with Wendover and Mark on.
Mm-hmm. So we can have line probably discussion, get connected. We will be part of this journey.
Yes, definitely.
Sorry, Jesse, one question. How does that then translate to improving the fit of the mask? Is it selection of the mask, or is it taking an existing mask and finding places where it needs to get better fit, or how do you use that information?
Yeah, so I mean, I'm sure other people on this call have much more experience than I do. Keith can probably talk to it. But if you want to get an N95 mask per NIOSH, like you actually have to go, and OSHA, you actually have to go get yourself fit tested. You have to go to this person that puts a beehive hood over your head before you can actually wear a mask. And it's not like you just choose small, medium, and large. They're not like t-shirts. Turns out the human face is very diverse, more so than the human foot. And so the current sizing that we have for N95 masks, I think there are about 6, 9 sizes, right, Keith? And so it's actually like a very hit or miss thing, and it's a try and guess method until they can find the right one that fits their face. And so we can solve that problem. We can take a look at your inventory. If you're a hospital, compare it against the inventory. And in this situation, many people, even though they wear a certain size, have to settle for a large, or a mask that doesn't fit their face. I know petite Asian female doctors like my sister-in-law who cannot get a mask that fits her face. She wears like the smallest size possible, and even then it's a little too big, and she's walking around wearing a large, the equivalent of a large. And so that's just because we are not good at understanding the sizes. And with this technology, we can help people get to the right size faster. Now, the second thing that we're doing is this, Shri. We're also taking a look at the 3D scanning of the face and working with people like Fogmask so that we can do the understanding of the face and work in part of the design loop. So we can bring the designer, the manufacturer, and the customer closer together so that we can get faster, more iterative design cycles because we can be more responsive to the customers who are buying the masks. Instead of benchmarking and producing masks against 29 to 45-year-old Caucasian males, we can make it much more responsive to the customers that they are looking for. The third thing that we can do is create 3D printed masks, which we've been doing. But honestly, those are quite expensive. And when we tried to get NIOSH approval and FDA approval on it, oh my goodness, we realized why government sometimes is antithetical to innovation. Because even though we have a mask that meets all the standards, even though we've done very rigorous testing at these kind of ISO certified labs and whatnot, the fact that it's reusable, which makes it sustainable, means that we have to go through a de novo FDA application versus a 510K application. And so instead, we'd like to focus more so on our core fitting technology and enable other people that make masks to get masks that fit to their customers better, faster.
That's fascinating. Thank you.
Yeah, I think that what I'd like to do is to ask about how this can be used at the entrance to facilities to determine whether somebody is wearing a mask with a tight fit entering the place of business. And this is where there's a huge need to do something to evaluate the quality of fit on the incoming visitors.
Definitely, and I think there are many ways you can go about that. I think the best way is probably to use image matching to create a library of off-the-shelf masks and then just take a look and check for things like a check valve. But in terms of how tight fitting that mask is on their face, I think this is something that, we could do someday if we put our effort into. It's one of the areas we've intentionally not done. Because coming from a place like Amazon, I'm very sensitive to data privacy and also the role of AI and technology in society. And we really want to be in the area of promoting individual liberty and promoting individual health choices versus being in the area of more so monitoring and gatekeeping. Even though we think that that's a need, it's not something that we feel particularly passionate about, which is why we've intentionally focused our development efforts on helping people create better fitting masks for everyone so that everyone will want to wear a mask that fits their face versus wearing color fitting masks because they have something that fits their face.
That's a really good question, and I think raises an interesting point about privacy. But I think Bob's question about fit, there's a flip side to this, which is that some LA Times reporters identified that even just the rate of usage of masks is a problem, there's a low rate of usage of masks in many large parts of LA, compared to say San Francisco, where the rate of usage is actually north of 90%. So, could this technology be used very simply to identify what percentage of people are using the masks and then target, public health messaging?
It can, right? But one of the things that we're doing now and working with people like Walgreens to do is to help lower income areas that are more ethnically diverse than say, San Francisco, and taking a look at those populations and understanding why it is they're not wearing their mask. And what we've learned just through our studies so far, because we've made the fitting technology so accessible, is that it comes down to how well it fits your face. Because if you have a face that isn't optimized for even the surgical masks, you're not going to want to wear it because it puts a lot of pressure on your ears and different parts of your face. And so we can actually show where it puts pressure on your face and why it's especially uncomfortable based on qualitative as well as quantitative metrics for persons of color versus Caucasian males in between the ages of 29 to 45. No offense to Caucasian males in between the ages of 29 through 45, like Keith, but my co-founder. But, you know, this is a thing. It's a matter of racial justice, equity, and democratizing the production and democratizing fit. And that's what we're all about as a company. And that's why we love Andover and Mark, because, you know, they believe in the same kind of ethos as us. They're all about environmental sustainability. They're all about making masks that, some of the masks that they had before this pandemic had valves on them. And so then they rolled out these non-valve masks because they knew that's what society needed today. And, you know, they go to Burning Man, so obviously they're cool people. So we really enjoy working with them. And we'd love to talk to other people that want to help us with our mission of democratizing fit for masks.
Well, that's very, very interesting. And I'd like to thank you for that presentation. Yeah, I'm sure that we'd like to continue that with you. Yeah, let's move on now to Eric and hear what he has to say. Eric, we're going to present your whole presentation here, so why don't you just walk us through it?
Thank you very much, Bob. So my main focus is taking what originally Dave Rousse mentioned to me, this N80 project, and just making sure it sees the light of day in time to make a difference in this pandemic. Bob, if you'd scroll down to the graphic that shows the measurement illustration, a couple pages down, it's this one here. So if you'd be kind enough to just zoom, pause right there, I want to draw everybody's attention to the depictions on the right-hand side. There's a great misunderstanding about what this ASTM standard is, especially since we've got N95, the N95 standard, which is something very specific, 95% particulate filtration. Understand that this ASTM effort is made of many parties with many special interests and a great interest in making sure that it is not misunderstood to be a respirator standard. So there's all sorts of contortions that were incorporated into the building of this standard that make it a little non-obvious. This is a measurement framework standard. It doesn't specify any particular performance level for a particular use case, like a school or a hospital or whatnot. It specifies a range. So if you look at the middle depiction, you'll see filtration. Yes, the standard has level 1 and level 2 defined in it, and those ranges are defined. So it's 20 to 50% is the ASTM level 1, and 50% or better is ASTM level 2. I have to confess, since there really are only 3 factors of merit, filtration, breathability, and fit, it seems to me a very unnecessary complication to add this construct, level 1 and level 2. We all know that based on the modeling, we need a pretty high level of filtration in order to beat this virus down. So in the depiction, we've put as a reference the N95 performance and a notional depiction that the mask perhaps on a box for a product that you might make might perform at a level of 80% or 85% or 90%, whatever it is. The intent with these graphics was to provide something that the general public could comprehend. I used to work in big aerospace, and they realized that most of the documents that we were all required to read every year were written for people with 22 years of education. And yet they had shop floor employees reading these jobs. We really have to recognize that while we may be fortunate to be super educated, my gardener has to be able to understand how to differentiate what mask will protect him. And so this graphic is just a notional shot. Sabrina and Catherine provided their inputs. Sri provided their input. We're trying to develop something that the general public could grapple with. And so for filtration, you can see we've indicated where the typical cloth masks perform and where the N95 performs. For breathability at the bottom, same thing. Breathability, the ASTM defines 2 ranges, and we indicate where the N95 range exists because it's quite a range, and where this mask might perform, and where cloth masks tend to perform. And then finally, fit at the top. So It's really important because we briefed the aerosol expert community, about 25 of the nations, the world's aerosol experts, Jose Luis Jimenez, Lisa Brousseau, we had the CDC on, we had Dave Rousse on, we had Sri on. We briefed the aerosol expert community because their first understanding of the ASTM standard is it's an ASTM 20 and an ASTM 50, which nobody wants to touch, right? So we really all need to understand it's a measurement framework, and we need to help everybody understand that this framework is an essential foundation that allows, finally, people to methodically contrast the cloth face coverings from true high-performance filtering masks. So if you'd be kind enough, Bob, to go to the next slide. So the question is, phase 1, phase 2, what's the first order of business? First order of business is to get massive protection out there as quick as possible. And Dave's done a fantastic job helping our country develop capacity for N95s that are disposable, but there isn't immediate adequate supply to absolutely squash this virus and allow people to be heavily engaged in the economy. To do that, there are two solutions that actually do fit immediately. If instead of using disposable N95s depicted in the upper left, we advocate reusable elastomeric designs in the upper right-hand corner that use flat filters, it turns out there's a much easier path to immediate high-volume production if you go with flat filters. They're more protected, you can use them for longer, they're easier to fabricate. The tooling cost is not measured in millions of dollars, and so you very quickly can take lines that are currently making upholstery that don't have enough work and turn them over to cranking out flat filters. And then at the bottom, this wonderful work that Sabrina and Catherine have done. I've worn the face brace while jogging for very long periods of time, and I find it to be absolutely fitting. The extraordinary thing about it is it's so easy to produce. It is the cost is minuscule. So on our shoulders is the responsibility to develop and deploy solutions that the poor working public could easily afford. And for my 2 cents, that mask brace combined with pleated masks, which can be made today in very high quantities. There's a completely different manufacturing process for the pleated masks. The equipment, Dave Rousse has explained that the 12 existing legacy mask fabricators, like the Honeywells and the 3Ms, they're making the formed N95s depicted in the upper left-hand corner. About 24 new companies jumped into the fray to help build out capacity. None of them or hardly any of them bought equipment that can produce disposable N95s like the one depicted in the upper left-hand corner. What they did is they bought equipment that can make the pleated 3-ply surgical masks. And so the point here is if you take the face brace and you combine it with the wealth of pleated masks, you can instantly give people not only an effective filter, but an effective fit. And so that's the genius of what they've done. And so when we talk about immediately trying to squash this virus, the reusable elastomeric displays, masks, and then also designs, and also this face brace with a pleated thing is a great fit. Bear in mind that when we brought this to the aerosol expert community, the first thing they said was, we don't want to talk to you unless you also have a solution for the extended medical community. We keep on hearing about visiting nurses, people who aren't under a formal hospital, who aren't protected, and they're being asked to reuse disposable masks. And so upon reflection, what we recognized is that if the tooling to make reusable masks, the elastomeric ones in the upper right-hand corner, if the federal government provides the few hundreds of thousands of dollars needed to scale up tooling or injection molding, the result is that you actually have dramatically increased the capacity that fits either an ASTM level filter or an N95 filter. And so with one campaign, with one federally funded Title III activity, you actually dramatically increase the availability both of the N95 supported solutions and the ASTM placeholders. I'm a little concerned about time. The rest of the slides go into demonstrating how this is actually the case. They're based on input from Dave Rousse and people he's introduced me to. They simply depict it, but I think, Bob, probably the most important thing to finish with is this slide here. What is the big play that we can all join in transforming this? CDC messaging is a tough thing to change. My view is that they would not change their message unless we proved that there was an industrial roadmap that was tenable. That's exactly why they didn't recommend N95s for the public back in March. So to get the CDC to change their message, we briefed 3 of Biden's coronavirus task force back in December. The response from one gentleman, Mike Osterholm, was, I want to do everything I can to support this. And then it's crickets. Went into the holidays, haven't heard anything. Everybody's fighting for the vaccine and so forth. So this week, we're reaching back out to as many of the people on Biden's task force that we can. We're also looking at going to the media, to CNN. We're also a remarkable suggestion came forward by John at the CDC. He said, you know, OSHA might actually advocate that for non-NIOSH governed situations, such as retail stores or schools, OSHA might actually be warm to recommending that those populations wear masks in the workplace that are made to this ASTM standard. I thought that was fascinating because I thought the whole NIOSH FDA stuff was totally out of bounds because they manage governed situations. He opened my mind to the possibility that we can go to OSHA and if we can get OSHA to recommend this for school teachers and so forth, that we would have that momentum we've been seeking to really transform things. The last piece I'd like to finish with is the ASTM standard only provides half the information. It doesn't specify what performance levels are needed to protect people in specific situations. We have had some assertions that we should leave it to the marketing teams to develop a recommendation. Of course, as scientists, the right people to declare what's appropriate are the aerosol experts. And so in briefing the aerosol community, we said, please ready yourself. You are going to be the ones who are going to have to recommend whether it's 80% or 85% or 90% particle filtration and what the fit needs to be. And I've actually come to the conclusion, and this is what I'm going to be pursuing over the next week, is finding 5 very credible aerosol experts that are trusted by the CDC and OSHA, and have them stipulate now for the general use cases that we recognize, schools, office buildings. Just end the conversation right now, come out from the very beginning. The aerosol experts, these 5 aerosol experts recommend this level of particulate filtration, this level of fit, and this level of breathability. Because if we don't go in with a very strong and clear message, the CDC and OSHA are then going to have to go figure it out themselves. And I fear that will only delay and create a long journey. We might as well come forward with a very strong answer that can get refined over time. But I think that's probably in the best interest of expediency. So I'm long-winded. I'm passionate about this. I'm happy to take any questions. I'm also sensitive to other people's presentation time.
Hey, Eric, this is Christine. I would say thank you so much to get the message out. We actually, as scientists and engineers, we often talking about, you know, efficiency, technology, and it's sometimes very challenging. We get the message to the right channel to get the public and the government kind of realize that you know, fitness, efficiency, not only the face mask, and also how effectively it will provide the protection to our people. So I will be very happy to join you, and we have the team of the experts join you to support the efforts if anything, you know, can promote for public health. in terms of the face mask and also air filtration as well.
Thank you, Christine.
Yeah, very, very interesting presentation, and I think you provide a perspective here that's the practical one that's very much needed.
Thank you, Bob.
I think let's move on now to Sabrina and Catherine Passaman and learn about the Fix the Mask. Ladies, it's in your court.
Awesome. Thank you so much, Bob. We're having a great time so far. So happy to share some information about Fix the Mask with you guys. So it seems like everyone here is pretty well aligned on the importance of fit. And as we're talking about this problem, the key thing that we want to address when coming up with a solution that really addresses the problem at hand with this pandemic is that there are a couple of things you need to consider. The first is that the solution needs to be comfortable and flexible. It needs to fit a variety of faces, and it needs to be scalable. So what Fix the Mask has come up with is a surgical mask accessory made of flexible medical grade silicone that goes over the outside of a surgical mask and creates a tight seal that ultimately passes fit testing to the N95 standard. And so just really quickly, I'm happy to demo it. I don't know if it's going to be too small in everyone's camera, but this is a regular surgical mask. And so if you take the silicone strap, you can place it over your head, over the top of your head like this. And you immediately get that high quality seal that everyone's looking for when you want to protect yourself from aerosol threats. And so when we're looking at what the solution has to do, as you guys know, we have to prevent the particles from going through and the particles from going around. And so where the folks on this call come in is that the melt-blown fabric that we're producing in huge volumes nationally today provides that high quality filtration that we're looking for. And so the key is, again, having that scalable solution that provides fit. And so Bob, if you can go forward a few slides. And so the key thing here, right, is that this has actually been validated not just by us, and we've collected rigorous amounts of data, trust us. We've actually had this concept tested and published in a variety of academic papers that have come out in just the last month. And so the first one is coming out of UNC Chapel Hill, which tests our initial prototype that looks at the viability of mask fitters as a concept. And so just 3 rubber bands providing an elastic seal around the top of a surgical mask was able to improve surgical mask effective filtration efficiency from 38.5% to almost 80%. So we've got some proof of concept in the works already. And this was initially released in December and published in December. If we look at just earlier this month, the University of Iowa also published a study, if you go to the next slide, Bob, where they did qualitative fit testing, again, using the same prototype across a variety of faces. And what they found is that when applied correctly, this can actually pass fit testing to the N95 standard when you create like a good seal with high placement of the neck strap and the head strap. And so this is really encouraging as well. But the most important piece of research that's come out recently about this is coming out of the University of Wisconsin, where they actually simulated in a variety of contexts the importance of fit. And by using mannequins that were able to breathe, they compared the efficacy of surgical masks and the effective filtration efficiency with the essential mask brace fitter that we currently have in production and in circulation today. And what they found is that when paired with a procedural mask, we're able to create something that's functionally comparable to an N95 respirator across the spectrum of particle sizes. And so if you could just go to the next slide, Bob. What you'll see is that we create that tight seal that prevents air from leaking around the outside. And comparing it for a procedure and surgical mask, we're getting that, the curve you're looking for at a 95% level effective filtration efficiency.
Is that using your current Fix the Mask, or is it using an earlier prototype?
This one's using, the data from the University of Wisconsin is using our current Fix the Mask essential.
Thank you.
And so then beyond that, we've been doing our own independent testing. The Saccharin fit testing qualitatively, dozens of people have passed the qualitative fit testing, the beehive that Jesse was talking about earlier. And quantitatively, we've been doing, just last week, Sabrina and I were retesting our braces after 6 months of use. And across a variety of faces, we were still able to pass the I believe it's the OSHA standard where you have to, jump up and down and read the rainbow passage and everything. So even when you're doing these rigorous tests that involve talking, grimacing, moving, you're still able to pass quantitative fit testing using the solution. And so the reason that we're excited about this is beyond this testing, it's also worth noting that we've tested this on a variety of faces. And the problem that Jesse's describing, right, where there's a variety of people who have faces that are really small, where this doesn't fit them. One phenomenon we've seen recently that's been really interesting is dentists all of a sudden are required to wear N95 respirators. So you have these new players who have to spin up this N95 fit testing, et cetera, and they don't have the N95 respirators that fit these dentists. And so what we hear often is that people come to fix the mask because they're saying none of the N95 respirators that we have on hand fit like the petite people on our staff. And so they use the essential mask brace in order to provide a stopgap solution for these folks as they're that actually fits some of these unique faces. Beyond that, as Eric had mentioned, the solution is incredibly scalable. I mean, you see it, it's one injection molded part, easy to clean, reusable. And, Dave was telling us earlier that we're making 274 million masks per month. What we believe is that with the essential mask brace, any of those masks have the potential to pass the N95 standard in terms of fit. And when we look at the ability to scale, we could scale to millions of braces in just a matter of weeks by spinning up additional tools. We've got tens of thousands in circulation today. We're really optimistic about this solution. And that's pretty much the gist of it.
Very interesting development. Thoughts or questions from people?
Yes, I have a question. First, it's a terrific innovation. And it really does turn around the value proposition of a mask, which currently is, it's not about you, it's about those around you. And that's why I think you get some resistance on the part of some people who say, what's in it for me? And now you've got a great value proposition. It's all about you, protecting you. So kudos to that. My question is, have you partnered with any makers of the flat trifold mask to have them sell the combination?
That's a fantastic question. We're in the process of vetting a variety of manufacturers at this time, but we fully intend to apply for NIOSH to become an N95 certified respirator.
Thank you.
When do you expect to complete the NIOSH certification?
Yeah, we had a really exciting meeting a couple weeks ago. We've met with a variety of people about this, but we've met with some folks who work for like a respiratory branch of the DoD and have sat on a couple different boards for approving this sort of device. And they said they saw no issue with this sort of device so long as it was paired with a surgical mask that meets the N95 standard. And I mean, I'm sure the folks on here know, but the N95 test doesn't even technically have a fit component to it. If you have a material that passes it and they do like an eyeball test, it's like, oh, does it look like it would probably fit? Then that's pretty much good to go. And so what we're going to be able to do, because we've collected so much data, have had backing from aerosol scientists and from researchers like across the country, we're able to provide an extra level of data to make our application more compelling. And our ultimate hope is that we can elevate the standard for what N95 respirators can be.
I have one more note here. The NIOSH qualification is two parts. First is passing all the tests, which is we have done and had that data months ago. The part that takes a while is updating the quality management system and making sure that both the filter manufacturer and us can maintain a quality throughout the process of creating these parts. So that's the part that we are working to bring up.
Do you expect that to happen in a month or two, or in the summer? Like what's the time frame do you think?
We're working towards a month or two is our goal.
Great, thank you.
Other questions? Well, I think this is a great contribution, and it does extend the potential for all the surgical masks to be used for N95. So it's terrific.
Yeah.
I think we also view this as what is going to be needed for the rest of the world. We have vaccines scheduled as late as 2024. Plus, we've got the problem of funding it. So I see these braces and fairly extended use of some of these surgical masks. And that brings up one last question. I don't know whether anybody from Ascend or Aston Johnson's on the call or not here, but with the antimicrobials, if they were integrated into these masks, could assure the longer use of these masks for a couple different reasons. One, you don't have to be as worried to change it as often to avoid contamination by touching. But also, if you can wash it less often or clean it less often with sprays or alcohol or something, it's going to get less distorted. So either way, the antimicrobial coating may be a way of extending the life of the mask. So I don't know if any of those people are on or wanted to say anything. Let's then finally turn it over for general questions or thoughts. Do people have arguments, thoughts, questions that they'd like to interject at this point in time?
I just do have one last note on Fix the Mask, Bob. If you just go to the last slide, Sabrina and I, as we mentioned to Dave, are actively vetting surgical mask partners. And we are also in the middle of fundraising our next round. So if you guys want to connect at all, definitely just feel free to shoot us a line. If you go to the last slide to hello@fixthemask.com.
Pull that up here. Yeah, there we go. Right. Okay. Yeah.
But one thing that I'm actually quite interested in that I really appreciate about Eric's standard, I think there's this thing that happens, from the marketing perspective where people conflate like N95 with like a specific mask. It's like that cup folded or that cup molded mask rather than a standard, which is what it truly is. I'm curious if anyone has thoughts as to how to sort of decouple those things to maybe level the playing field and help folks wrap their heads around a bit like the ability for a consumer to pick a mask that works for them, basically.
Well, one of the things that we've proposed, in this 5-step approach is the involvement of some of these very large organizations like SGS and Eurofins that will provide a test seal which shows what the efficiency of that mask is, but also the assurance that there is quality control. It's one thing to say with a Chinese mask that it was tested once and made and passed any of the efficiency tests. It's another thing to produce millions of those a month and have them all meet that efficiency level. So these organizations are providing that kind of analysis. They have quality control inspections at the manufacturing sites. They have quality control inspection at the distribution points, and they do the analysis of resistance and filter media testing and so forth. So I do think it's a very valid question, but one that maybe should be addressed holistically, and that's why we came up with that 5-step process.
Yeah, I do have one. I thought one thing that's not really captured in a lot of the testing is what is the fit factor achieved by an average user versus someone who's trained and someone who's knows how to do this. And if I had to guess, it would occur to me that the fit factor for a typical off-the-shelf N95 for an average user would be quite low, versus something like your solution, which if they just try it and it works, that's a huge gain in and of itself without having a lot of complicated fit testing. So comparing the real world experience of end users, is that something have you looked at that, or to see what the benefit would be in a for a variety of just like untrained, but it's like if we wanted to do this for senior citizens in the country, just like Germany's doing, what would the outcome be of sending them a standard mask versus something like your mask?
Yeah, I mean, anecdotally, we're totally on board with you, Sri. I find it's way easier. I can tell immediately if there's a leak in my mask. It just like blows cold air out down my neck, and so I'm able to adjust it pretty quickly to make sure I fix it. But we are in the process of putting together a more rigorous study that compares, the average cup molded mask to our mask for the average person to see if they're able to get a better seal with each, and also see if it fits a wider variety of faces. I do think that the problem of having like dozens of models of N95s that vary slightly, that have issues, and I mean, I've even heard from my friends who like work in healthcare that if you're not able to find a good fit, like you're kind of just sometimes you're just out of the game for some of the procedures that you need. Otherwise, you're wearing a PAPR, which is kind of insane. Like I don't want to be dressed like an astronaut when I'm trying to do surgery. So yeah, I think that there's definitely something there, but we don't want to make any claims without collecting more data. But we're optimistic.
Yeah, I guess having a test site as a senior citizen, a home or like would actually give a lot of information about the effectiveness of these solutions, because ultimately that's what where things are headed. And if you can, say, hey, there's a huge gain just by having it.
I think you've got a very good point there, and maybe we can enlarge upon your ideas there and some of our ideas. Our ideas were these safe bubbles, and that say you'd have safe bubbles at fitness centers, but since you've got physical therapists and other people at these fitness centers, that can certainly put people through the various different motions you need to test masks and so forth, that they could become the local fit testing experts for the area, and not only would it allow 100% of their people of their customers to be back working out with these efficient masks, but would give them an extra revenue. And the same thing for large malls. Why not have sell the masks and then do fit testing and get paid for it at these places? So maybe all these ideas come together to provide this expertise in a much more robust way.
Yeah, absolutely. I don't know if you saw, there's this Andrew Yang tweet going around that it's like amateurs talk strategy, professionals talk logistics. And we've got lots of professionals on the call here. So if anyone's interested in talking a little bit more about the logistics of getting fit testing, more widely, make it pervasive sort of throughout the country, we're definitely happy to hop on a separate call and work out those details.
I think a related point is also that the fit of the N95 mask can improve using your fix the mask, because that's what I thought, is that you can actually, N95 masks themselves, are not easily fitted, and so by adding your tech thing to it, and if you can show an improvement of the average user's fit with an N95 mask, then it just makes the point very clear that this is really beyond.
Yeah, we've actually done that kind of testing, not on a wide scale, but we've tested each molded N95 cup respirator along with the KN95 or KF94, and we've been able to bring up the fit factor from something that is below, it's between 3 to 50, up to 200 plus, the passing score being 100. So we would love to do that on a wider scale as well.
Yeah, it seems like that's a big deal.
Other thoughts or comments that people have today? Well, if you do have thoughts, send them to us. And, we're writing these alerts on a daily basis. We'll be scheduling more of these webinars. And I'd like to thank everybody for contributing today and look forward to the next one.
I guess I have one last thought, a question for the audience, rather. If we're going to do something like what Germany is doing and Germany, Austria, and soon to be France and maybe other UK, they're all going towards masks for senior citizens and vulnerable groups. What would we propose as a group to the Biden administration? I think that's kind of a sort of ask that, and maybe there's the answer. We can work on that.
Yeah, I think that's an area that Eric is very much involved in there. I think it's obviously the key question.
Yeah, and I think they can execute this within weeks. Several. It should really be happening right now.
And as Eric pointed out in his, his presentation, that's something that should be kept fairly simple and try to get the approval of people who are known to be experts. So,
and I think, Sri, one other thing to maybe consider is, as Sabrina and I have been going through doing our research, it seems like over the last couple of months, it feels like people don't really have questions about masks anymore. Even people have like sort of hardened their own perspectives on how masks work and how they can work. I think that sort of undoing that is maybe the real work here, changing like public perception and undoing those preconceived notions to make them more backed by science. So I think that the approach of leaning on the expertise of some of the folks in the community is definitely promising.
Right. Actually, we had a very good conference last month, and we did receive a lot of comments. One of the comments actually very related to Eric just mentioned. They says, hey, we actually talked about the building safety and the face mask. We address a lot of issues. And the question actually from audience, also from a couple of influential people, says that you have to get the message to government, to the people who make the policy, because what we presented. So Eric, I think from technical standpoint, we have a lot of things, and we would like to work with you. What we should deliver, what kind of message we should deliver to our Biden administration, and not only the mask and also building IAQ, this kind of things. Probably it's something from professional standpoint we can address better than just the policy, current policy makers.
Yeah, I think Christine's got good points. And by the way, some of her speakers were were experts such as Peter Tsai, who invented the melt-blown electrically charged mask in a webinar just a few weeks ago. So I think they're a good resource as well. Any other questions, thoughts? Well, again, thanks everybody, and we'll look forward to doing this again. Bye now.
Thank
you.
Thanks, Bob.
Thank you. Thanks, Bob.